Okay, in this video, we are going to talk about the free response questions for the AP Precalculus exam. So the first thing to know is there are going to be 4 FRQs. 2 of them are calculator, 2 of them are non-calculator. You get 30 minutes for the 2 non-calculator and 30 minutes for the calculator. Collectively, they're worth 37.5% of your score on the exam, which is a very weird percentage, but whatever. My advice on any free response question, try to get as many points as possible. The entire exam, just try to do that. But never leave anything blank. Always do real work. You never know what they may or may not give you some partial credit on. You never know how the points are really distributed. So just give it your all. The problems are going to be in the Blue Book app, so like you're going to see them on the screen, but then you're going to write everything on paper. This is called a hybrid exam. That may not always be the case, but in this year it definitely is. And make sure you've downloaded the Blue Book app and you take a look at it and make sure you can do everything. So now what we're going to do is we're going to roll through what the FRQs look like, and I'm going to do, I think the equivalent of like 4 FRQs as I go through this. Nope, 8 FRQs, kind of 2 of each. So let's see. If I remember, I'm going to put the PDF of the blank of this in the description. So if it's not there, ask me about it and I'll get to that. All right, first free response question. Now, these basically always look the same, which is kind of, in my experience, unique amongst AP exams. But the first FRQ is always going to be about function concepts. It's always going to be calculator. Essentially, you're always going to be given information in 2 different ways. You're either going to be given a graph and or a table, so choose one, graph or table. And then you're going to be given some kind of function definition, like f of x equals blank. The first part of this question, I should mention, you're only going to have to deal with linear, quadratic, exponential, and logarithmic on this. Kind of says that in the description of the FRQ. So part A, you're going to have to evaluate a composition. It could be f of g of x, g of f of x. Might they vary that up at some point? Maybe, but they haven't really in the past. Then you're going to be asked to do something else that involves the table or the graph that you're given. So you'll either evaluate an inverse, you're going to have to like find some input-output value pairs, or you might have to like solve an equation that involves really just looking at the table and figuring out what's going on. So that's part A. In part B, you're going to be asked to solve an equation. So this will be for the one that they define for you, like f of x equals blah. So, this one is basically just using your calculator. Solve an equation, find the zeros, all those kinds of things. Then you're going to be asked to determine the end behavior with correct limit notation. When you do that, you should always write out one of these things. So I've typed up the exact things that you should write. I highly recommend that you memorize these things. One key to this is all of these limits, your calculator can do this. Just let your calculator do the work. It'll spit out the answer. As we do examples, you'll see what I mean. I'm using a TI Inspire, which has like pretty print, which makes it look like the math that you're actually doing. Just let your calculator do the work. And you should for sure memorize these, right? Like, why would you not? All you have to do is write down one of these. You will get a point on the exam, maybe 2 points. I don't know how the points are distributed. For part C of this thing, I'm guessing that it's going to be one of these 2 things. This is not as well defined. I think you're either going to have to identify the model, which again, this is a memorize it type of situation. So a linear model is the best fit because the average rate of change over consecutive equal length input value intervals is a constant. So you're going to see that equal length input value intervals is a constant part over and over again. Just memorize it. A quadratic model is the best fit because the successive second differences of the output values are constant over consecutive equal length input value intervals. Exponential because the output values change proportionally over consecutive equal length input value intervals. Now, the only one that doesn't involve consecutive equal length input value intervals is logarithmic. If you find that the output values have the same equal length, over consecutive equal length output value intervals, if you find that the delta y's are always the same, you're going to choose logarithmic, provided that it's not linear, but you would have already discarded that notion because if delta x is the same, then you're definitely choosing either linear, quadratic, or exponential. As soon as delta x isn't the same, now you're probably choosing logarithmic no matter what happens, but you got to make sure that the delta y's are the same. So logarithmic is best if the input values change proportionally over consecutive equal length output value intervals. Now you'll notice exponential and logarithmic are almost the exact same explanation. It's just that the input and output have switched, which makes sense because logs and exponentials are inverses of each other. So you want to memorize these for sure. I make my students memorize them and just write them down. And again, if the delta x is the same, you're choosing between three of them. You got to look at what's happening with delta y in that case. So just do more work. If the delta y is a constant and delta x isn't, because you've already discarded that notion, then it's definitely a log. All right. And then there's a part C. The other thing I think you might have to do on part C, rather, is I think you might have to talk about inverses. This is another memorize it type thing. F of x doesn't have an inverse because there are input values of f that are not mapped from a unique input value. And then I would give an example. So you're going to look in the table and see the same y value twice, or a horizontal line intersects a graph twice, or whatever. You'll say both f of x1 is equal to k and f of x2 is equal to k are true. And then you'll fill in the specifics. So it's f of 3 equals 5 and f of 8 equals 5, something like that. Or you can say that f has an inverse because f is an increasing or a decreasing function. For example, they might just tell you that. Or each output value of f is mapped from a unique input value. That I think you should definitely make that statement. Each output value is mapped from a unique input value. I think you could also have a limited domain where they just say the x values in the table are 1, 2, 3, 4, 5, and that is the domain of the function. That's actually easier because then no matter what, you can just look through the table and be sure, you don't have to know increasing or decreasing at that point. Okay, so I do think you should memorize these. Just memorize them. There's not that many things to memorize. You have a week at this point, but in the future, maybe you have a year. Who knows? I do think a wildcard type of thing that they might ask about here would be concavity, perhaps. And so you could say, for example, the average rates of change are increasing, therefore the function is concave up. Or maybe the average rates of change are decreasing, therefore the function is concave down. I think that would be fair, according to the description they give. All right, let's do a little bit of practice here on this one. So this is FRQ number 1, part A. Selected values of the function g are given in the table below. The function g is continuous on its domain. The function f of x equals -3 log base 2 of x plus 2 plus 2. Too many 2's there. All right, so when I wrote these problems, it turns out I wasn't as creative as I was hoping to be, but that's probably okay. This is what it will look like. You're going to be given a table or maybe a graph, and then you're given a function. Part 1, m of x is f of g of x. We're going to find m of 9/2 to 3 decimal places. I don't know, in my examples, they don't always work out that great, but the process is exactly the same. So first thing we're going to do is we got to find f of g of 9/2. So we need to know what g of 9/2 is. We go up to the table. At 9/2, g is 27/8. So now we're just doing f of 27/8. That's a calculator. So here on my calculator is what I did. And 3 decimals, -5.279. There you go, 3 decimals, always. The next thing that we're going to do is solve the equation g of x equals 27/8. So this is bad. I should have chosen any other value, but I didn't. So we know that g of 27/8 means that x is just 9/2, but it says give your answer to 3 decimals, so I'm going to go 4.500. Those 0 at the end aren't mandatory, but I like to do that just so that when I look at my answers, I know that I did correctly round everything. So for this part, what you're going to end up doing, you're going to look at the table or the graph for the output, and then you're just going to list the input. So this part A is almost always based on, well, I think it always is, based on either the graph that they give you or the table that they give you. Let's take a look at another part A. So this is just another example of what's going on. So you can see, given a table again, given a function, we got to find h of g of x, or h of g of 1/2. So m of 1/2 is h of g of 1/2. I like the way that I did the work on this one better. G of 1/2 is 2, so now we're finding h of 2. And h of 2 is a calculator problem. So I define the function, I plug in 2, I get -3. It'd be better if that was a crazy decimal, but I didn't think about it ahead of time. So we just get -3.000. And then the next question, did I just duplicate the previous one? I don't know. We're solving g of x equals 8. G of x equals 8, go to the table, look at the g values, find 8, and you can see that 4 goes with that. There you go. It could have asked you for like g inverse of 8, like they could have told you that g of x has an inverse or something, and then said what is the value of g inverse of 8, and then you would say g inverse of 8 is equal to 4. Either way, let's take a look at some part B. So this is still FRQ1, but now some part B's. We want to, so now basically you just move on and you're using the function definition that they give you. You're going to like solve an equation, then you're going to talk about end behavior. I think that's always going to be the question. So this one says solve h of x equals 1. So total calculator question. I define h of x. I just use solve. You could use a graph, however you like to solve these things. And then you write your answers. And then determine the end behavior as x increases without bound. That's the limit as x approaches infinity. So on my calculator, I just ask, what is the limit as x approaches infinity of h of x? Calculator says infinity, and then I write down the thing that I memorized. So that's why we're memorizing those things. You don't want to spend time thinking about them on the AP exam. Just like have them memorized, be able to just blow through them. So this always looks like this, so I'm not going to do more examples of it. Let's look at what some part C's might look like. So again, we're given everything. Based on the table, which of the following models best fits f? So linear, quadratic, exponential, logarithmic. Remember, if delta x's are the same, it's either linear, quadratic, exponential. If delta x's are not the same, it's definitely logarithmic. So we look at the table, and you can see like all of our delta y's are just 5. It kind of like jumps out at me that that is the case. So delta y is a constant, which means either it's log or it's linear at that point, but you can see like the delta x's are just not the same. So this is definitely logarithmic. That's it. You don't have to like explain anything in that part. The next part is going to ask you to explain. So this is sort of like a multiple choice question. You're just choosing one of them, but you have to be able to defend it. But you've memorized the defenses for these, right? You're going to say why this is the best fit. So I can see that to get from 1x to the next, I just constantly multiply by 3. If you're not sure how to do that, just take like 3/4 and divide by 1/4, see what you get. Take 9/4, divide by 3/4, see what you get. 27/4 divided by 9/4, see what you get. And you get 3 each time. So to get from one to the next, you just keep multiplying by 3. All right, so then we just write down our justification. A log model is best because the input values change proportionally by a factor of 3 over consecutive equal length output value intervals. We have it memorized, so we don't have to think about it. We're just kind of filling in the blanks. Let's look at another example. So again, it's multiple choice. I look at this and I see that all the delta x's are the same, so it's either linear, exponential, or quadratic. I look at the delta y's are not always the same, so it's not linear. And I get a feel for it that this is probably exponential, and in fact, maybe it's another bad example because you just multiply by 3 every time. I don't know why that happened when I made these, but that's okay. So exponential is definitely the answer here. And then we just write down exactly what we memorized for why exponential would fit. So that's why we're memorizing. It's not a mystery. Just memorize those things. Again, the PDF should be below. Get it. Start memorizing. So I said there was one other thing that I thought maybe part C would look like. Over equal length input value intervals. I forgot. I think that they might ask you about, does the function f have an inverse? So if you go back, you can see the reasoning that I gave for why something would or would not have an inverse. But the first part of this is also kind of just a multiple choice. It's a yes, no. Does f have an inverse function? So if you read the problem, it says f is continuous and increasing for all x in its domain. An increasing function will always have an inverse. A decreasing function will always have an inverse. So I'm going to definitely say yes here. And then for my reasoning, I'm going to write down the thing that I memorized. F of x is an increasing function. F has an inverse function. Each output value of f is mapped from a unique input value. And that's all I would write. If the answer was no, then probably at first they wouldn't have told us the function is increasing because obviously it has an inverse. You'd look at the table. So like quadratic is really the only example that we have where it would not have an inverse. You would look in the table and like maybe f of 3 is 4 and f of 9 is also 4. And you would just look at that and be like, nope, because at x equals 3 and x equals 9, we get 4 as the output both times. So each output is not mapped from a unique input. There is not an inverse. So that's what another option, I guess I would say, for part C. Let's take a look at what I think question number 2 is going to look like, which again, it's like pretty prescribed. Like they didn't leave themselves a lot of options for how to write these FRQs, so you should definitely be familiar with them and know what you're doing. All right, so you're going to be given a scenario to read through. It describes a situation. They call this like modeling with non-trig. It is calculator, so that's great. So here's the first thing to know. Part A, you're first going to write a system of equations. That is it. They have to give you the model, so you don't have to like worry about that. And then in part 2 of part A, you're just going to solve that system. And I'm going to suggest that you let the calculator do the work. I would not use regression on this because like the form that they give you doesn't need to match up with the regression forms on your calculator. On the other hand, solve or solving a system by graphing, however you like to solve systems of equations, just use that. So I'm always going to use solve. And then make sure if you get decimals, 3 decimal places always. So in part B, I think they're pretty much always going to ask you the same thing in part B. I mean, part B1 is always going to ask you to find the average rate of change, and then to reason about it somehow in like part 2 and 3. So average rate of change is algebra 1 slope. It's just delta y over delta x. It's y2 minus y1 over x2 minus x1, however you like to remember it. Slope of a secant line, I'm going to talk about those a bunch. And then you have to answer some question, like approximating using it, or describe the units. So for units, it's just the units of y divided by the units of x. So if the units of y are cars and x are weeks, then when you find delta y over delta x, the units are just going to be cars divided by weeks, so cars per week. So, you know, if you got like 15 cars per week, then on average, on the time interval, whatever, the dealership is selling 15 cars per week, something like that. And then there's I think that part 3, or part 2 and 3, probably part 2, is often just going to ask you to approximate something using the average rate of change on the interval. So what we're going to do for the average rate of change, we're going to use a secant line. So a secant line is just a line through the 2 points that they tell you to use to find the average rate of change. So I always use point slope on that. So y minus y0 is m times the quantity x minus x0, right? Now the other thing, that's pretty easy. Then you just take whatever value they give you and you plug it in. I'm going to do a couple examples of that. Then you're going to have to like justify something about it. Is it an over or an underestimate often, or just like the concept of are you getting over or underestimates? I would recommend that you just memorize these things. A little picture that you draw can greatly help you out. So like if a graph is concave up, the secant line on the interval between the endpoints of the secant line lies above the curve. So using it to approximate a value within that interval will give a value greater than the value found from the model, or it will overestimate. And then if you are outside of that interval, you get underestimates. So draw a picture and the answer kind of jumps out at you. But you should definitely memorize these. Like I'm just going to like spit them out as soon as I've got a problem and I need to do it. The other thing is you might need to talk about concavity and rates of change. So concave up, rate of change is increasing, and the average rate of change is also increasing. Concave down, rate of change is decreasing, and the average rate of change is decreasing as well. So let me just draw some concave up and down things. So x squared is the classic example of concave up, and negative x squared is the classic example of concave down, but also an exponential function can really illustrate it, and I guess a log function as well, but concave up and concave down. So make sure you just have a feel for concavity. And then in part C, I don't know, I find part C of question 2 to be like the least easy to predict, I guess. So you just have to justify some conclusion about it, or like a limitation. So like, I always say like, just go back and read the problem again and see how it makes sense in the context of this question. So maybe they'll ask you about the domain or the range. It's like if you're selling things, it doesn't make sense for you to be selling negative things, so that could limit your domain. Or they could specify a domain and ask you the range. They could ask you to interpret the output, you know, like what does it mean when you find like f of 8? And then they'll frequently, I think, ask you, you know, you have data that spans from 2 to 8, and they'll say like, okay, so should you be more confident in a value of, t equals 5 or t equals 35? And since 5 is in between the data values, it makes sense to use the approximation there, but like that other value was so far out of the range that it doesn't really make sense. That's like interpolation is using your model between the bounds, and extrapolation is using your model outside of the bounds. Interpolation is a better idea than extrapolation. Like, it's not reasonable really to use your model like well beyond the data points. All right, now we're doing them. So this is what part A will look like. Consider the following ordered pairs. There's going to be more context to it, but I just didn't feel like writing it out. You basically just read through a paragraph and pull out the ordered pairs that are in the paragraph. And then you look at the model that they give you, which they have to give you, and you just go from there. So 4, 3.6 and 6, 3.9. And then the model is a natural log of t plus 1 plus b. Part A1 is always write a system of equations. So we're just going to take these ordered pairs, so 4, 3.6, and plug them in. So we get a times the natural log of 4 plus 1 is 5, plus b is equal to 3.6. That's it. And then our second equation, we'll use the second point. A natural log of 6.1 is 7, plus b is 3.9. That's it. No one should leave that blank. Everyone on Earth can get that point. Then if you know how to use a calculator, you can definitely get the next point too. So I just use solve on my calculator. I define the function. The one thing I can imagine my students getting wrong on this is forgetting to put multiplication symbols in between the parameters like a, b, c, d, whatever, and the variable in the function. So if you have to do a times t, make sure you do a multiplication sign t. That's the only thing I could imagine going wrong. And then just write it down to 3 decimal places. So let's take a look at what part B will, generally speaking, I think look like. Approximate the average rate of change of m of t on the interval from 4 to 6. Okay, average rate of change, algebra 1 slope. So I'm going to say that this would be using these points, m of 6 minus m of 4 over 6 minus 4. Then grab your calculator, just have it calculate those values. So 3.6 minus 3.9 minus 3.6 over 6 minus 4. That turns out to equal 0.15, so I'm going to write it as 0.150 because I like to have 3 decimals everywhere I look. And that's it. For part 2, use the average rate of change found in B1 to approximate the value of m of 5.100. So this is the part that I think you might find the weirdest. So I'm going to first write the equation of a line that passes through 4, 3.6, and 6, 3.9. I'm going to use point slope form for that. So it's y minus 3.6 is equal to the slope, 0.150, times t minus 4. That's how we start. Then we want to take the value we're given, 5.1, and just plug it into that line. So we're going to say this is an approximation of the m value. So m of 5.1 is approximately 3.6 plus 0.15, and then the quantity 5.1 minus 4. This is calculator, so we just let the calculator do the math on that. We get m of 5.1 is approximately 3.765. I didn't show that on the calculator because that's just arithmetic. But that's how you're going to do that if they ask you to approximate something. It doesn't matter what value they give you. Just go right to it. Write your secant line. That's algebra 1. Plug into it. Super good. The next part, based on the model you found in, is the approximation in B2 an overestimate or underestimate of the actual value? Okay, so if you look at it, we have like a log function. And we found that the value of A was positive, and I don't even remember the value of B. But also, you can just have your calculator. Oh, A is 0.892, and B is 2.165. I can see it right on that calculator page. That's going to be a log, like a normal log. So it's increasing and it's concave down. Here's like sort of a graph just on the interval from 4 to 6. So we can like see what's happening. The secant line is below the curve. So graphing it gives you a really good idea of what things look like. Highly recommend that you just graph it. You could graph it by hand really quickly, but you have a calculator, so why not just let the calculator do the work? All right, and then we write up our standard answer to this. So concave down, secant line is below the curve on the interval from 4 to 6. And then if the value is between 4 and 6, we're going to get an estimate that is less than. If the value that we're given is outside of the interval 4 to 6, we're going to get a value that is greater than. So since the graph is concave down, the secant line on 4 to 6 is below the graph. I think that's a good thing to just establish. Since 5.1 is within the interval, the approximation using the average rate of change is less than m of 5.1. That's all you need to do. It's not really mysterious, but if you have never done it, it's a weird question. All right, let's look at another one. This is part C of kind of the same question. Empirical observations show that after t equals 6, the actual quantity begins to decrease. Explain why the error in using the model grows for t greater than 6. All right, so we said, and we looked at our graph, and if you're not sure, just graph it again, or go back to your calculator and stare at your graph page. We said that the model that we found was increasing for all of t, while the actual data is decreasing for t greater than 6. So if one thing is increasing and the other is decreasing, I think it's safe to say the error is going to begin to grow after t is greater than 6. I think that that's a fine answer. I don't know. If they're looking for more, I will revise this video for future years. But for this year, I think that that is a perfectly fine answer to this question. All right, I'm going to take a look at another. This is another of FRQ2. So you can see we're given 3 points. Again, you're going to have to read through a giant paragraph or a small paragraph and pull out these ordered pairs. They're not going to just be given to you this way, probably. But you will just be given the model. So f of t is at squared plus bt plus c. This is where I said my students, I think, could get in trouble by just typing that into their calculator. You actually have to type a times t squared plus b times t plus c. All right, part A is write a system. So we take the first point, we plug it in. We take the second point, we plug it in. We take the third point, we plug it in. We have a system of equations. That's good. Now it's calculator. We're just going to let it solve it. You can see here I've done a times t squared plus b times t plus c. Please don't mess that up. You get some kind of error. Actually, I think you'll just get like false as your answer when you try to solve. And then I used solve system of equations. It spit it out. I did a weird thing to show you all 3 answers. You have to like scroll through to find those answers, but we can write down our answers. Negative 0.476, negative 1.189, and 3.288. And that's it. Those are points that everyone should definitely get. I would argue like the next part is also points that everyone should always get. Approximate the average rate of change on some interval, right? So it's from 2.012 to 7.021. So we just set it up. Our model name is f, so I do f of 7.021 minus f of 2.012 over 7.021 minus 2.012. Then it's calculator, so you just let the calculator get that value for you. So I got negative 5.490. For part 2, it's again, we're just going to use the secant line with a slope that is the average rate of change to approximate this value. So our secant line, you can choose whichever of the 2 points you want. I'm going to choose the first one. Sometimes they will specify which point you have to use. If they said like the average rate of change and the value of m of 7.021, you would have to use the point 7.021, negative 28.532. That would be like a setup type of point. You'll get the same numerical value either way, but you got to do what they ask you to do. So I'm going to plug this in. So I get y minus negative, so plus 1.031, our slope, and then t minus 2.012. And then it's plug in. So we plug this in. Calculator says negative 34.094. And here's what that kind of looked like on the calculator. However you want to do it, you just got to get those values to pop out for you. And then I'm going to go to a new page to do part 3. So in part 3, based on the model you found, is the approximation over or under. Again, you kind of have to like import your values here to know what's going on. So we have a quadratic with a negative a value, so that opens down. So we're essentially dealing with this situation. So we can see that our model is concave down. So the the secant line between the values is below the curve, and then outside of the values, it's above the curve, and that's the key point. So the graph is concave down, so the secant line is below the graph on the interval, and above the graph for t greater than 7.021, since 8.034 is greater than 7.021, the approximation using the average rate of change is greater than f of 8.034. So I always go back to like I'm in 9th grade English when I write the final answer. Like I like to restate the words that they used in the problem. I don't know. Just do the best job you can. If you use my answer, my like techniques, you're definitely going to get the points. But however you like to do it. And then here's part C. Should you have more confidence in using the model f of t to predict a value for time t equals 6 or t equals 9? Give a reason for your choice. So I look at the data and I'm like, the data goes from 2 to 7 basically. So 6 is in between those, so you would expect the model to be good there. 9 is outside of that, and like anything could happen once you get past 7. So I don't think it's as reasonable to use 9, to use it for 9, I should say. So I'll just say the given data is on this interval. We should have more confidence in the model at t equals 6, which is in the interval, than at 9, which falls outside of the interval. I think that that's a plenty good explanation of why you should use it for 6, and you should be skeptical of 9. All right, we are up to question number 3, and it's interesting because you have 15 minutes per problem, and I'm at like the 30-minute mark, so pretty good timing, I guess. Let's see how this goes. So this is, I think some people are afraid of this. I don't think you should be. This is the trig modeling question, so you're going to be given a scenario, you got to read through it. Basically, again, you just have to peel off ordered pairs that are written in the problem, and you have to somehow peel off the amount of time that it's taking to repeat itself. It'll be given to you somehow. You just have to work it out. Like if it says 10 revolutions per minute, then it's doing, that's like 1/10 of a minute per revolution, so that you can get 10 revolutions in a minute. 1/10 would be the period of the function. You just got to pull those pieces of information out. So here's what part A will always look like. You're going to be given this graph. Literally this graph, it will be printed in the answer booklet, and you have to write ordered pairs for each of these things. So that's not bad. Then in part B, you're either going to have to find a sine equation or a cosine equation. There's like an infinite number of answers to these questions. You just have to get one of them that is correct. I have a really, I think it's good, video about writing equations from graphs. You should definitely check it out. I will try to remember to link it below. Well worth your time, I think, especially if you're like a little shaky on this. But you either have to write that, and then the question really is just write down the values of A, B, C, and D. I wouldn't be surprised if they print those in the book as well, but they say they're not going to. Then for part C, it's, from what I can tell, it's literally always the same. So you're going to look at the graph, and then you're going to be given 2 of the points, like from, I don't know what they were called, like F to G or G to J or whatever. And for part 1, you have to say if the function is positive or negative and increasing or decreasing. It's multiple choice. So you're going to have to choose one of those. And then for part 2, you're going to have to describe the concavity of the graph and determine whether the rate of change is increasing or decreasing. So these that I've written below are like verbatim what you should write. Like just memorize them and write them down. So definitely memorize these. Because the graph of f is concave down on the interval from t1 to t2, the rate of change of f is decreasing, or because the graph of f is concave up on the interval, the rate of change of f is increasing. That's it. It's great if you understand it, but for the purpose of the AP exam, if you find yourself writing concave down, you better say that the rate is decreasing. And if you find yourself writing concave up, you better say the rate is increasing. Like, you just got to do it. All right. And then this handy little graph here shows you where are the part of the graph they've given you. It just identifies things. So like from F to G and G to J, the function is definitely decreasing. From J to K and K to P, the graph is definitely increasing. And then F to G, we're concave down. And also from K to P, we're concave down. And then from G to J and J to K, concave up. So those are the only things that can happen. So you definitely know that going in. Like there's no excuse to not know that. The only thing that you could potentially get wrong is maybe if you misconstrue the scenario and you get like the function is positive or the function is negative part wrong. But I think that would be hard to get wrong as well if you really just give a thorough reading of the problem. So now we're going to look at a couple examples. I think I'm going to do 2 of these. So a weight is attached to a spring that is then hung from a board. I got this from an OpenStax textbook. I like OpenStax, kind of recommend it. As the spring oscillates up and down, the position h of t of the weight relative to the board ranges from of the weight. I don't know what I'm saying here. The weight is like the thing that's moving. I was like, weight is like a measure. I don't know what I'm doing. Relative to the board ranges from -1 at t equals 0 to -7 at t equals -3. So right away, you know this thing is always negative. So assume that h of t is a sinusoidal function. Sinusoid is like a catch-all term for sine and cosine graphs. So just because it says sinusoid doesn't mean it needs to be sine. All right, so peel off your ordered pairs, here we know that like we are told that the highest this thing ever goes is -1. We're basically told that the lowest it ever goes is -7. Right in the middle of -1 and -7 is -4. So now we have a lot of information about this. Now you look at the problem and you're like, at t equals 3, we're at -7. So that point J, I'm just going to label as 3, -7. We also know that this thing starts out at -1, and at t equals 0, we are there. So I'm going to say f, which is that little maximum there, is 0, -1. If it takes me from 0 to 3 to go from a maximum to a minimum, halfway between that is 1.5, and that's where we should hit that middle value. So 1.5, -4. And now I know it takes 1.5 to go each of these increments. So if I'm at 3, the next one will be at 3 plus 1.5, which is 4.5, -4, and then add 1.5 again, we get 6, -1. Those are your ordered pairs. Plenty good. Now the next up, this is where you should watch the video if you're really not sure of how to do this. I'm going to kind of like go through it quickly, but we can see we're looking for a sine curve. So we can either start at G or we can start at K. It doesn't make a difference. They're both sine curves if we start there. So I'm going to start at G. So I go from like an intercept to a minimum. So it's a negative sign in my case. If you start at K, you're going from intercept to maximum. That's a positive sign. So answers will vary and they will accept multiple answers. The period here is 6 because it takes 6 units of time to go from maximum to maximum. There's a lot of ways of doing that. I think that's the easiest one. So our period is 6. The period is always 2 pi over b. So we just solve for b and we get pi over 3. I already said that this is the curve I'm looking for, so I'm going intercept minimum. That's negative sign, which means the value of a, our amplitude is 3, but the value of a, because it's a negative sign, is -3. And then we need to know our like starting value. So we're starting at 1.5 because we chose the point G. And then we also you kind of just know immediately D is -4. That's actually the one that you know that's the easiest one to get, is the midpoint, I think. So the next thing we want to do is we just want to like fill in our function. So I'm going to write this the way that I always write it. So h of t is -3 sine of the quantity, pi over 3, quantity t minus 1.5, and then all that minus 4. The only thing to watch out for here, like a and b are definitely -3 and pi over 3. The way that I write my models is I usually do t minus c. That's how I learned it, and I think it conforms with all other models that you learn. So like, I think everyone should use that, but College Board doesn't. So we have t minus 1.5. Look up at the model and look at what we have. So they have t plus c. They will always have that, t plus c. We have t minus 1.5. So for our purposes, c is -1.5. Just make sure you get that. And then d is -4. And that's all there is to it. I would say the next part is even if you get part B wrong, and maybe part A, you can still get part C, like without a doubt. So here we go. We got that this was our equation, but like crucially, just from reading the problem, we know that we're going from -1 to -7. And that means that our function is just always negative, which means we've already eliminated A and B as options, right? So either h is negative and increasing or h is negative and decreasing. I didn't even read the problem yet. So we're going from the point J to the point K. So that means we're on this little part here. So that's definitely increasing. So negative and increasing. We circle C, I guess, or maybe you write down h is negative and increasing. I don't know, whatever. That's our answer for sure. And then we need to describe the concavity. Well, on that interval, we are definitely concave up. And if we write concave up, we have to say the rate of change is increasing. So there you go. The graph is concave up. The rate of change is increasing. It's not as scary as people make it out to be. I think the scariest thing is that there are a lot of words and people seem not to like to read these days. Okay, new question. Ferris wheel is 25 meters in radius, boarded from a platform that is 1 meter above the ground. So this is what I'm talking about. You got to just read. The 6 o'clock position on the Ferris wheel, I think on the actual exam, they would give you a picture and it would be like all spelled out for you because they don't count on you having these cultural references like an analog clock, for example. But the 6 o'clock position on the Ferris wheel is level with the loading platform. So the bottom of it is 1 meter above the ground. The wheel completes 4 full revolutions every 50 minutes. So we have to figure out how long it takes to do 1 revolution because that is the period. And then the function h of t gives a person's height in meters above the ground. t minutes after the wheel begins to turn. So again, it's the same thing every time. You're going to be given this and this graph and asked for the 5 points. So that comes down to reading the problem and figuring out what's going on. So the radius is 25 meters. That's given to us. They could have said the diameter is 50 meters, and we would have to just figure out the radius. I don't think they would do that to you, but maybe they would. We need to figure out how long one revolution takes. So if you can do 4 of them in 50 minutes, it's 50 minutes for 4 revolutions. That's 12.5 minutes per revolution. The period is 12.5. And then we need to figure out if the period is 12.5, then each of these points is 1/4 of the period apart. So the increment is the period divided by 4. So our increment is 12.5 divided by 4, 3.125. And now we got to figure out what's going on. So I think they're going to provide you with like at least a picture, maybe not like it's not going to be all labeled up for you probably, but a picture I think it might look like this. And so at 0, you're at the bottom. It doesn't actually matter which way you're going in this case. So at 0, we're at the bottom, and then I went, what'd I go? Counterclockwise. So at 3.125, we get to that rightmost point, then 6.25, we're at the top. 9.375, we're at the left. And then if we add 3.125 again, we get to the 12.5 that we need to, because that's 1 full period. So I think that's what's happening. I'm now going to take this information and create my ordered pairs. So we know that at t equals 0, we're 1 meter above the ground. The 6 o'clock position, that doesn't really matter. It's just the bottom, right? So here's 0, 1. So you just find the point that they're really giving you. You know the increment, and now you just start labeling. So if I go 1 increment to the right, I'm going to go up. How much am I going to go up? The radius is 25, and so I will go to 3.125 and then 26, because it was at 1 and you went up 25. And then if I go 3.125 again, I'm going to end up at 6.25. These numbers might be, the x-coordinates at least, might be worse than what you would see on the exam. I don't know. They probably put I hope they put a lot more thought into this. Now, I'm going to have to go backwards to make this work, and I don't think that's a problem, because it still does describe where you would be. So negative 3.125 and 26, and negative 6.25 and 51. The only way this really wouldn't make sense is if they limited you to say, like, t must be greater than or equal to 0, which creates, like, a weirder problem, because now you got to, like, just keep going to the right until you get to that like 6.25, and we'd have to put positive 6.25 at F and then keep counting from there based on the picture that they have given us. So I think they're going to accept anything for this as long as it's valid points, right? These are periodic, infinite number of answers. Now in B, we got to do the equation again. This time we're looking for a cosine function, and it doesn't stipulate positive cosine, negative cosine. I'm going to choose to start here at the bottom, so I'm doing a negative cosine. You could choose to start at F, right? And then your starting point is negative 6.25, and you just plug in accordingly, and you go with the flow. You could also start at positive 6.25. Both F and P would give you positive cosine functions. I'm choosing a negative cosine, so I already know that the value of A is negative 25. Again, watch the video about how to write equations from graphs, and this will not scare you at all. It's very straightforward. Very algorithmic. The period is 12.5, which I've changed to 25 over 2 because this is a non-calculator problem, and I just would prefer to work with fractions. So B is 4 pi over 25. The start that we chose is 0 for this example, but you might have chosen negative 6.25 or positive 6.25, which would also change your value of A from negative to positive. And the other thing we just know is that D is 26. That's at midline, or the sinusoidal axis. So we're going to write down our equation the way that I always write it, which involves writing t minus 0, or I would do t minus negative 6.25 or 2 minus 6.25. And then we write down A and B, and then we notice that, they always say t plus c. So if t plus c, then in this case, c is going to be 0 no matter what you do. But be aware of that. That's the main difference between what I traditionally will teach and the AP exam. And then D is 26. And that's it. Not to be afraid of this. For part C, everyone can get these points regardless of what's going on. In this particular case, remember the minimum was at 1 and the maximum was at 51. Always positive, which means you've already eliminated 2 of the answer choices. And also you can see a typo that persists through these problems where I wrote HF is negative and increasing in part C. I don't know. I probably cleaned that up in the PDF, hopefully. All right, so definitely positive. And then we're going from F to G. F to G is decreasing, so positive and decreasing, that's definitely B. And then we always have to answer the concavity question. So regardless of whether you got the previous one right, you can see from F to G that this thing is concave down. So we'll say the graph is concave down. And if you say that, you better say the rate of change is decreasing. So that's what we have. All right, so there is one more type of FRQ. Let's take a look at it. I think of this one as like an Algebra 2 test plus some trig. You need to know the directions going in. There's a couple of things that are really specific. Well, there's really one thing that's very specific. So the domain is assumed to be the set of all reals, unless otherwise specified. Angles must be in radians. I think everything that you do in AP Pre-Calc is pretty much in radians. I don't think you ever have a reason to use degrees. Solutions to equations must be real numbers, which means I think that no solution is probably not an option because no solution is not a real number, but I wouldn't hold to that. But also you're not going to get imaginary numbers. Determine the exact value of any expressions that can be obtained without a calculator. This is a big deal. In particular, I would say the log base 2 of 8 is the most striking example of it because the log base 2 of 8 is the log base 2 of 2 cubed, and that's 3 times the log base 2 of 2. That's just 3. You can simplify that. Cosine of pi over 2, all the unit circle values you should know, and then inverse sine of 1 is pi over 2. All the inverse sine, inverse cosine, inverse tangent values, you should have those memorized. I have a lot of videos about like inverse trig and the unit circle. If you want to check those out, probably a good idea, up to you. And then the algebraic rule is basically the same. You should just simplify all algebra. Like you wouldn't leave 2x plus 3x, you would make that 5x. I think it's weird that 5 squared times 5 cubed is in this set of directions because I feel like that really applies to the previous one. So you wouldn't leave 5 squared times 5 cubed, you would write that as 5 to the 5th. But then you can do that without a calculator, so you would also work out what 5 to the 5th is. And if you don't know what it is, just do 5 squared times 5 squared, 625, multiply that times 5, you know, that kind of thing. I don't know what the limit is on that. Like, I don't think they're going to ask you to do, like, 7 to the 9th or something. And then, like, x to the 5th over x squared, etc. Another weird one here, which is, I mean, basically logs are the weird thing. You wouldn't leave natural log of 3 plus natural log of 5. You basically wouldn't leave two logs that have the same base in any problem. So log 3 plus log 5 is log of 15. Because if there's addition between the logs, you multiply the things inside the logs. And then you got to show your work. So we're just going to do a bunch of these. Here are like the things you need to know. You need to know all about exponentials, log, trig, and inverse trig. For part A, you're going to be asked to solve two equations. Or part B, sometimes they switch those. I don't know why they do that. And then part C is another equation that you have to solve, and it's just the way they express the equations are just different. In part A, it's usually like solve g of x is 28 or h of x is pi, something like that. And then in part C, we'll see it when we get there, but then they're just like find the inputs that give this output. I don't know why they break it up that way. For part B, you just have to rewrite things. So either you're rewriting things with exponents and they specify the way it should look, or you're rewriting things with logs and they'll always say like write your answer in the form, you know, log base 2 of expression or something like that. They'll also say no negative exponents. They're just going to tell you what to do. These are your log rules in case you're unfamiliar with them. Addition between becomes multiplication within, subtraction between becomes division within, and then coefficients become exponents, or exponents become coefficients. I've never seen one where they ask you to expand a log. It's always contract, but like I think it would be totally fair to say expand this log. So far, we haven't had to worry about domain on these FRQs. So unless they specifically ask for the domain, I wouldn't bother with it. You also are going to need to do a trig identity, like show that this equals this or write this in terms of that. These are the fundamental identities that you should have memorized for sure. So we got some ratios, we got some reciprocals, and we got Pythagorean. I'm going to assume that you know them. If not, pause the video and memorize those. All right, here goes. Oh no, wait, there's one more thing. I would say that like for the last one where they say find the input values that give the output values, or find the values in the domain that yield these values, whatever. It's going to be probably a trig equation that will involve inverse trig in some capacity, or like an exponential that involves like a substitution in some capacity. all bets are kind of off, but they kind of like are hemmed in by these things. Make sure you know your inverse trig values, right? So memorize those. I draw these little pictures of the unit circle. Let's do some problems. So you can see I've edited this. I accidentally said g of x equals 9, and then doing the problem, I ended up with 5 to the 9th, and I was like, there's no way. So the functions g and h are given. G is a log, h is a trig function. Solve g of x equals 2. This is really what the problem will look like. You just got to be comfortable with it. So we just set it equal. Then for logs, I always remembered as base, answer, exponent. So 5 is the base, x plus 3 is the answer, 2 is the exponent. So you do base to the exponent equals the answer. So base, answer, exponent. So 5 squared is x plus 3. X plus 3. So, there you go. And then trig, you might have to use an identity. The double angle formulas in particular might come up here. So this one doesn't involve that, but we have 2 cosine 3x plus 5 equals 4. We got to isolate that cosine of 3x. So we get cosine of 3x is negative 1/2. So x is between 0 and 2 pi, which means 3x is between 0 and 6 pi. So I got to write all my answers for 3x. And then here's a unit circle, right? Negative 1/2. You probably have it memorized. It's 2 pi over 3 and 4 pi over 3. But if not, draw the circle. You could literally draw the entire circle. It should not take you much more than 90 seconds. So our first ones are 3x could be 2 pi over 3 and 4 pi over 3. But we have to keep going until we get to 6 pi. 6 pi is just 3 revolutions. So we got our first revolution. I'm going to add 2 pi to each of these. That's 6 pi over 3. That gives me 8 and 10 pi over 3. That's my second revolution. If I do another revolution, I'm going to add 6 pi again. So it's 14 pi and 16 pi over 3. I've done 3 full revolutions, which gets me up to 6 pi. Now I just divide all these by 3. Those should be our answers. That's the kind of thing you'll run into. There could be some variety, but generally speaking, that's it. All right, the functions j and k are given by j of x is natural log of x plus 3 minus 2 natural log of 5 plus 3 natural log of x minus 2 natural log of x plus 5. And then k is this trig thing. But first, let's do j. Write it as a single natural logarithm without negative exponents in any part of the expression. So, this might be log base 3 of all these things, log base 8 of all these things. They're just going to tell you your result should be of the form, in this case, natural log of expression. There you go. The way that I deal with these always, always have and probably always will, is if there's a plus in between them, it goes in the numerator. If there's a minus in between them, it goes in the denominator. And then if there's a coefficient, it becomes an exponent. So what we're doing is I usually start with one log and then a big parenthesis. Now I'm going to build my numerator. So anything that has a plus goes, so a plus between them, not like within x plus 3 doesn't count, but we have basically plus natural log of x plus 3 plus 3 natural log of x minus 2. So this one's going in the numerator. And then the 3 will become the exponent, like coefficients become exponents. So this goes in the numerator, x minus 2 cubed. And then anything with a minus goes in the denominator. So this 5, but the exponent, so that's 5 squared, which is 25. And then this x plus 5, but that 2 is an exponent, so the quantity x plus 5 squared. And that's it. There's nothing more to be done. Let's take a look at the next part. There is a domain thing going on there, but they don't ask for that, so I'm not going to put it. Okay, let's look at k of x. So k of x is cosine over 1 plus sine plus tan of x. It's possible the things that I chose here are going to be harder than what's on the exam, but you'd always want to practice harder anyway. We want to write k of x as an expression in which cosine is the only trig function. Okay, so we're looking for just cosines. So k of x starts out as this. I'm going to change tangent to sine over cosine right away using the ratio identity. Then common denominator is a really common thing to do, so I'm going to do that. So the first fraction needs cosine over cosine. The second fraction needs 1 plus sine over 1 plus sine. The only thing to do here is expand the numerator. So I'm going to expand cosine squared plus sine squared over 1 plus sine times cosine. Okay, then I see sine squared plus cosine squared. That's a Pythagorean identity. That's 1, so this just becomes 1 plus sine over 1 plus sine cosine. Then I can cancel a 1 plus sine. I get 1 over cosine. They said our only expression should be cosine. That's it. If we had somehow ended up with cosine cubed minus 35 cosine over, I don't know, something, 52, That would be our answer. So like you could have cosine to any power, you can have coefficients of cosine. It's just that there can be no other trig functions. There can only be the one that they ask you for. So that would be the end of that problem. Let's take a look at the next one. I think on the real exam, they do a better job of distinguishing, like my part A had a question that's sort of similar to this, but I'm just giving you options of what I think it'll look like. So the function m is given by 2 sine squared minus 1 plus cosine. Find all input values in the domain of m that yield an output value of 0. They seem to like tangent on these problems, by the way, so I would really like take a look at tangent. So first up, we just write down our equation. We see sines and cosines. You got to get rid of one of those functions. Sine squared is 1 minus cosine squared, so let's do that. Let's clean this up, so I'm just going to distribute. Now I'm going to collect like terms. I hate when there's a negative coefficient, so I'm going to divide through by a negative. Now I'm going to factor this thing, right? So 2 cosine squared factors into 2 cosine and cosine. I need to get a negative middle term, so it's going to go plus 1 minus 1 like this. And now we set each of the factors to 0, so either cosine of x is negative 1/2 or cosine of x is 1. We're solving for all values in the domain. That means we need to generalize our solution. So cosine of x is negative 1/2. We've actually encountered this before in this fake problem that I made up, so not a great problem. So that was at 2 pi over 3 and 4 pi over 3, but because we can keep looping around, we're going to add 2 pi n. And then cosine is equal to 1 only at 0. So 0 plus 2 pi n, where n is an element of the integers. I think that'd be your answer. I would point out that you can definitely simplify 0 plus 2 pi n without a calculator, so maybe I should have simplified that to just 2 pi n. I wouldn't take off for that, but maybe they would. All right, so I'm going to do basically one more example of like FRQ number 4, and then I think we'll be done. So we got the functions g and h. Remember, it's going to be 2 equations that you have to solve. So first up, we have sine of 2x minus cosine is equal to basically 0. So sine of 2x minus cosine is equal to 0. This, again, if you have 2 different trig functions, you're kind of in trouble. So we need to do some, well, the argument here is what's causing a problem. Sine of 2x is 2 sine x cosine x. You got to know the double angle formulas, and then we can factor out a cosine, and then we can set them each equal to 0. We're only solving from 0 to 2 pi this case, so cosine is 0 at the top of the unit circle and the bottom, so 0 and 3 pi over 2. And then sine is equal to 1/2 on like the right side, so that's going to be, the top, not the right side. So it's going to be at pi over 6 and 5 pi over 6, and that's the answer. If you're not sure about the unit circle, knock it out. Just draw a unit circle, fill in all the values, fill in enough values so that you can definitely answer this. All right, let's look at the next one. We got 5e to the 4x minus 4e, and that has to equal negative 2e. Okay, so we're just going to add 4e to both sides to get this. We're going to divide by 5 to get this. I'm going to take the natural log of both sides because e is the base. If it was 2 to the 4x, I would take the log base 2 of both sides. Honestly, I would probably take the natural log of both sides anyway. I take natural logs no matter what I'm doing. But we'll take the natural log of both sides. Natural log of e to the 4x is just 4x. And then on the right-hand side, we have the natural log of 2e over 5. And then divide by 4. We get this. Now, I don't actually know if they will accept this answer, or because there's a property of logs that we can use here, and in using that property, we'll get the natural log of e, I think maybe we need to keep going. So I'm going to do that. I'm going to use the property that multiplication within becomes addition between. So I get 1/4 the quantity, natural log of 2/5 plus natural log of e. The natural log of e is 1. So here's an alternative answer. I'm curious to see in years to come, or as they put out more information, which of those answers they would accept. My guess is probably both. I don't think you would intend for this question to be that hard, but like, I don't know. All right, let's look at another part B, which will be rewriting things. So we've got another log expression. I just use natural log. It's just what I use. Could be any base. And then, or it could be something like an exponent thing. Like you could have 3 to the x squared to the all to the 5th divided by 3 to the 32nd. And you have to write it as like 3 to the ax plus b type of situation. That's just properties of exponents. I don't think of that as pre-calc. I think of that as algebra 2. But let's see if we can do this one. So again, we're just going to start with a natural log and then a giant parenthesis. Anything with a plus goes to the numerator, coefficients become exponents. Anything with a minus goes to the denominator, coefficients become exponents. Then we have to make sure that we simplify. So we'll get this thing in the numerator, so x plus 3 to the 5th. We'll get this thing in the numerator, that's x cubed squared. We have to simplify that. This will go in the denominator because of the minus, so we have the quantity 5x to the 4th cubed. So make sure you use your parentheses there. And then this will go in the denominator as well. So the quantity x plus 5 cubed in the denominator. Now we look at it and we have x cubed squared, which is x to the 6th. And we have the quantity 5x to the 4th cubed, which is 125x to the 12th. So we have this. And then x to the 6th over x to the 12th. We can cancel that down. We're just left with x to the 6th in the denominator. That's our answer. They don't want the domain, so let's not give the domain. Let's look at k of x. So again, we're writing this as cosine of x. I'm a little worried I actually inadvertently wrote the exact same question, just looks very differently. So k of x, I'm going to use ratio identities like for basically everything. So tangent is sine over cosine. Cotangent is cosine over sine. So we have sine over cosine plus cosine over sine. I know that cosecant is 1 over sine, but it just messes things up right now. So I'm going to get a common denominator in the numerator. So I'm going to multiply the first fraction by sine over sine and the second by cosine over cosine. It gives us sine squared plus cosine squared over sine times cosine, all over cosecant. Sine squared plus cosine squared is 1. And then at this point, I'm going to change cosecant to 1 over sine. So we have 1 over sine over cosine. 1 over sine times cosine, all over 1 over sine. I'm going to do my keep change turn. That's how I learned it when you have complex fractions. So the sine goes to the numerator, so sine over sine cosine, cancel the sines. We get 1 over cosine again. I think that's what we got last time. So we just found out that 2 weird things are equal to 1 over cosine. But it's in terms of cosine, so that's good. And then we have this. The function m is given by m equals 4 arctan of t over root 3. And then we want to find the input that yields the output, arc cosine of negative 1/2. So they're testing a bunch of things in this question. First of all, you have to know the arc cosine of negative 1/2. That's definitely 2 pi over 3, right? It's the top half of the unit circle. Where is the x coordinate negative 1/2? That's at 2 pi over 3. So our problem becomes this. I'm going to divide by 4 to get this. If you run into inverse trig function of something equals an angle on this problem, just take the trig function of both sides. So like this looks complicated, it looks like you have to think about it. Nah, if you take the tangent of both sides, the tangent of inverse tangent, they're going to kind of cancel out on you. And then you have the tangent of pi over 6. So just do that. And we get this. Tangent of pi over 6 you should have memorized is root 3 over 3. And then I was a little surprised when I solved this. You just get t equals 1 in this case. And that's it. So that's like a lot of examples of each of the FRQs or things that I think will be on the FRQs. Obviously, with time, I will get better at this because there will just be more information. But I think for this year, if you can do all of these things, you're pretty well set up. I think anybody can get at least 20 of the 24 available points. Know how to use your calculator, memorize all the explanations, memorize the inverse trig things that you should know, the log and exponent rules. I think you'll be okay. So I hope this was helpful, and good luck.